Hey, hi. It's been a while since I made a video, but no problem. Today I came with an excellent concept, and we are going to do some forensic challenge in today's video. And from Hack the Box, I'm going to choose an interesting challenge called Chase. So it's a Wireshark challenge. So we are going to use the tool Wireshark to analyze a packet capture, and we are going to understand what exactly happened from that packet capture. So without wasting further time, let's start. Now I logged in the Hack the Box platform, and in Hack the Box, I'm choosing labs and challenges to see the list of available challenges. And you can see the various categories. I'm going to choose the category forensics, and our challenge chase is in retired category, and going to forensics. And here you can see the highlighted one because I already took this challenge to showcase in this video. I'm going to take this challenge once again, and it is called Chase, and the challenge difficulty is easy. So let's get into the challenge. First of all, before you are getting into the challenge, you need to read and understand the challenge description. You need to know the exact scenario to understand what you need to do. And for that, let's read it. One of our web servers triggered an AV alert, but none of the sysadmins say they were logged into it. We have taken a network capture before shutting the server down to take a clone of the disk. Can you take can you take a look at the PCAP and see if anything is up? So what they are trying to say, they actually observed some abnormality from their web server, and they pretty much sure none of them logged in, and they also captured some packets from the server. So by seeing that packet capture, we need to find what exactly happened. So it's going to be an interesting challenge, and to take this challenge, you need to download the packet capture file. You can simply click this button and you can download. I created a directory for Hack the Box challenges, and for the forensic challenge, I created a separate directory, and I created a folder called Chase. I'm already downloaded this Chase challenge file, and we are simply going to unzip this file to get the actual file. And it is asking for the password. You can see the file name, which was actually zipped into. So to get the password, you have to click this and see the password here. I already downloaded. So simply clicking this password and it already copied. It is in the clipboard. So let me paste that password here. Now it extracted that exact packet capture file. Now it is quite simple. We are going to spawn the Wireshark application and we are going to open that packet capture called Chase. So it's quite straightforward. You can see the packet capture, it opened in a few seconds. And whenever you open a packet capture, you need to know its properties, actually what sort of packets it is having, how many packets it is having. You need to know those details. To get those details, you can go to this specific tab, statistics. If you click the statistics, you'll be able to see the capture file properties, protocol hierarchy, conversations, endpoints, packet lengths, various details about the packet capture file. And I'm clicking the packet capture file properties. So here it is giving some details about the file. And you can see the file hashes here. It is in the PCAP format, and the first packet captured on this date and the last packet captured on this date and time. So it was totally ran around 6 minutes and 3 seconds. You can see on which operating systems they captured this, and also the operating system, hardware and the operating system. And they also gave the application details here. So at the bottom you can see the interesting thing, beneath the statistics. So they gave the number of packets. Actually there are 216 packets given here in this capture, and all those packets are displayed. So these are the important things that you need to know before you are start handling that capture. And apart from this, you can also see the protocol hierarchy to view what are all the protocols present in this packet capture. So here you can see the protocol hierarchy. These are the protocols present in this capture, and you can see The first one, it is frame, of course, lower level, and Ethernet, IPv4 protocol, layer 3, and after IPv6, I mean IPv4, you can see the layer 4 transport layer, UDP protocol, and also TCP protocol is present. And the UDP protocol, what is the application? It is DHCP and DNS, dynamic host config protocol and domain name system. And if you come to the TCP, you can see it is also having the transport layer security, which means HTTP over SSL or HTTP over TLS. So it is encrypted, and also you can see HTTP here, and they gave certain details beneath HTTP, and at the end they gave some data. So this is how you need to know what are all the protocols involved in a specific capture, any specific capture. And we have seen there are a couple of UDP protocol called DHCP and DNS. So why don't we filter both protocols and see what exactly happened? So I'm just filtering DHCP first. From this, specific packets, DHCP packets, I can understand something. So here you can see the information. It is requesting the DHCP. The first packet is DHCP request. And if you want to know more about this packet, you can simply see this specific pane. So you can see the layer 2, I mean the bottom layer, the specific, I mean when your data on the wire, what it will be. So those kind of details given here, the lower level, the lower layer data. And going to the next one, I can see the data link layer details. It gave the hardware address of both source and destination MAC address. And here also they gave a hint, it's going to be an IPv4. Obviously there are IPv4 addresses involved here. And going to the layer 3 IPv4, you can see the source for from this packet 20, I mean 22 22 22.7, that's the source, and this is the destination. So it looks like a DHCP request, right? So what it is, that 22.7 is the source, and it is requesting some IP from 254 IP, which means it might be a gateway or it might be a DHCP relay. So that is what you need to understand from here. And it is a UDP protocol. They gave the geolocation also for this IP. And you can see the port details 68 and 69. I mean the source port is 69 and the destination is 67. And you can see the dynamic host configuration protocol, the message type, what kind of message it is and all. So this is the DHCP request, nothing interesting in this DHCP packets. Moving to the next one, DNS. We have seen two protocols. First one we have seen, and the next one is DNS. What it is trying. So you can see this is the source 22.7, and 22.2 is the destination host, and it is requesting some DNS data. It is querying for the domain go.microsoft.com. That is the DNS A record. And you can see further the request and the DNS response. I don't see anything interesting from this capture. However, I am going to look at this packet in depth, whether I'm going to get any interesting info. But so far, it is not giving any interesting info to me. So moving to the next one. So let's do some filtering for HTTP, because we have seen HTTP protocol is present in this capture. So here you can see the HTTP protocol. We got few packets for HTTP. And what I'm doing, I'm just choosing a packet randomly and right clicking, following the HTTP stream. So when I follow the HTTP stream, I can see some human readable data, because HTTP is not encrypted. So whenever the data transfer is occurs in transit, it will be plain text. So anyone who intercept the traffic, they'll be able to read whole thing. If you are transferring any password, any sensitive info, then it might be stolen. So that is the thing in HTTP. That is the dangerous stuff in HTTP. So people, it's an obsoleted one. People are not often using HTTP. And okay, now let's see what we have got here. And I'm just scrolling down to understand. Just take an overview. So there are a lot of things here. Um, let me see this first. First of all, what it is actually. 22.5 is the destination, 22.7 is the source. You need to keep that in mind. So it is actually sending some request to 22.5, and the request is just to get the specific, it is just spawning the specific HTTP server. So nothing specific path given here. So it is simply giving HTTP colon double slash that IP address. And what is the response? 304 not modified. So if you have no idea what is the response code 304 not modified, feel free to use Google, our best companion. 304 response code. The HTTP 304 not modified client redirection response code indicates that there is no need to retransmit the requested resources. It is an implicit redirection of a cached resource. So that is what they gave. Um, okay, all right. Moving to the capture. So nothing interesting thing in this specific communication. Going to the next one. Here it is again as accessing the same destination, but it is requesting the specific image. So this is the web server. It is requesting the specific image from the web server, but the response is still same. You can see the referrer. It is actually giving the web server URL and the same response. So we can ignore this communication as well. Going to the next one, I can see it is trying to access a file called a path called upload.aspx, and the user agent is Mozilla. From the Linux machine they are trying. They were trying, and if you see this, it is giving the detail. It is actually giving the 200 OK, which means it is giving some response to the requester. And also you can see the server details. Actually this web server is running on a Windows machine. We have already seen in the packet uh, the properties there they gave. It is captured on a Intel processor, a Windows hardware, and obviously it is actually using the Microsoft IIS web server. And yeah, we got an idea now what kind of web server it is. And when they access upload.aspx, it is giving some response, and you can see what was the response. So here they gave a HTML page, and it looks like let's see what kind of page it is. But you need not to copy the data from here and you can paste it in a file. It's a tedious job. Instead you can simply capture all the involved files in Wireshark whenever, especially in the HTTP communication. For that you need to go to this file, export objects, and you need to choose the protocol HTTP, and it will list down all the files involved. And you can see upload.aspx, that file we were uh, showing some interest to view, and I'm just clicking that file and saving it. I'm choosing the same chase directory. Let me get into the path forensics chase, and here I can see the upload.aspx. I'm opening it in a text editor. Okay, so this is the data we have seen before. uh, it's a HTML page actually, but since it is a Microsoft server, the file extension is ASPX. And I'm just opening this specific ASPX page with Firefox. When I do that, I can see it is giving this page. So this is the server page, and where when someone enter a valid authentication key, they'll be able to upload some file. So that is what we can understand from this web server page. So this is the page requested in the packet capture. We can see that clearly. And closing it as of now. Let's continue to look at that conversation. And moving down further, I can see another page. So what is exactly happening here? So here you can see the request. I mean the request now. It is using the post method. Post method is generally being used whenever someone is trying to send some data to the web server. So we can understand we have seen upload page. So now in this specific packet, they are trying to upload something into the web server. So we can understand they are trying to upload some spooky stuff into the web server. So that's what is happening. And you can see what kind of data they are trying to upload. And if you see the description here, so here actually you can see the authentication key, and they are giving the authentication key as admin. So it was asking an authentication key, right, in that page that I have shown earlier. So they used the authentication key admin and they uploaded the file, and this is the file they were uploading. And from this page, I mean from this data, we can understand they are trying to upload some malicious script. And you can see this syntax of this script. The syntax is nothing but it's a visual basic script. So they are keeping this visual basic script within this script tag. And I'm scrolling down further. I can see the HTML. Within the HTML tag, they gave certain things. So interesting stuff here. And if you want to see this, uh, first of all, let's understand what is the response. So this is just an input. The things given in the highlighted in the red was the input, and the things highlighted in the blue was the response from the web server, and it gave 200 response. So the upload was succeeded, and they also got a success response. And here in the success response, you can witness a message called upload file uploaded. You can see the message here. So this message will be deployed once the specific content uploaded into the web server. So that is what you would see when you download, when you see this specific uh, I mean when you put this content in a file and see it through the browser. And moving to the next one, I can see another interesting thing here, cmd.aspx. This looks like another page, and the same server, and the response is okay. So what kind of response it is? So let's see this. So it gave HTML, the same page, but I don't know what kind of, I mean, let's see this in the browser. So you'll be getting a better view. So let's go to this export object section, HTTP, and choosing the cmd.aspx. And the packet number is 29. So you want to cross check it, you can go ahead and cross check. And the packet capture, it is 29. Now the 29 is selected. So that is what we are going to see. And let's download this. Download it. And yeah, it is present here. So Firefox, opening it with Firefox once again. Now see what is here. So in this page, so they are actually executing, they are actually triggering some executable, and they are also giving the argument here. Look at this cmd.exe. They are actually triggering the command prompt through the specific web page. So this is another web page. The cmd.aspx is offering a web page where we will be able to execute some command and also give the arguments for that. So net user is to get the user details of the machine, I guess. So what they are trying to do, they are uploading a web shell within the, I mean in that server, and they are once they reach this specific page, they are executing some command, and they are giving some arguments. So that is the page all about. And moving to the conversation once again, scrolling down further, we can see some other interesting stuff. Now again they are posting something in command.aspx. and you can see what sort of command they are posting. So this is actually obfuscated, but you can see here the human readable word Windows system 32 cmd.exe. We have seen just now in that page it was triggering cmd.exe, and also what they are doing additionally, it is actually calling the cert util. Cert utility, it is living off the land binary which is being used to download a file from the internet, a wget or curl equivalent. And you can see they are using the parameter hyphen url cache split, and they are calling a source actually, and here the file name is nc64.exe. So what they are doing, they are trying to download some file. So that is what happening here. So when they upload this, when they post this specific content within the, I mean in the web server, it will again call this source and execute certain thing. So that is what going to happen. So it looks like a shell, a reverse shell, and you can see the response here. The response is given here in this packet. So let's see this response once again. I'm moving to this one, cmd.exe, packet number 37, correct. I save it. I'm replacing it. Okay. Now again I'm calling it with Firefox. Oh, it is the same page, nothing new. And going to the next one, again they are calling cmd.aspx, but this time only the request we can see. They are posting something into the server, but no response given here. So yeah, there were so much of information in that. So let's do one thing. I'm simply, when I follow this TCP stream, I was able to see some list of data, the list of communication. I'm simply changing the TCP stream equivalent to 1. I'm going to see the second TCP handshake. And in this, I'm using the same, following the TCP stream. And here you can see some interesting thing. So what is exactly happening from the, actually it is trying to get some nc.exe file. So you can see the first two letters here, mz is denoting the PE, portable executable file, the program that can be executed on Windows machines. So that is this, and you'll be able to export this file. It looks like some netcat kind of application, and closing this one. So that is what we have received from TCP stream 1, going to TCP stream 2, and here let's follow the same. Once again, the executable file nc64.exe, and when the shell is uploaded into the web server, it is reaching the source. 22.7 is the source. It is reaching the source to get this specific file. So that is the thing. And moving to the next stream, stream 3, and in this stream 3, let's see what we are getting. Following the TCP stream, yeah, here you can see some interesting stuff. Who am I? So once they got that reverse shell, they are trying to execute some command. Who am I? They executed and they got the response for that. ipconfig they executed, they got the response for that, and they are executing a PowerShell command, and execution policy is bypass, and they are invoking a web request. Invoke web request is the PowerShell command led to request some URL, I mean, request something from the web server, and they are requesting something from 22.7. So that is the URL, that is the source machine. And You can see this specific file name. This file is very interesting one, but it's a text file. This might consist of some interesting info, but let's understand this. They are actually calling this URL and saving it as public file. And you can see the outcome for that. Now, the next one is the cert util URL cache split hyphen f. They are again calling this URL and storing it in this specific path. So this is the stuff. These are the commands executed through that shell they have uploaded. And closing this one, let's move to the next TCP stream. So this one is TLS, the encrypted one. But let's see that what we are getting. Some random characters, nothing interesting thing, and nothing interesting here. And moving to the next one, next to TCP stream 5. So if I see this fifth stream following the TCP stream, and here finally they are trying to get some file called some random characters and .txt, and the server is responding okay, and you can see the content within the file. So this file contains the content. Hey there, nothing is interesting, only a message hey there. And TCP stream sixth one following it, same stuff. Cert util user agent, through cert util they are reaching this specific file, so that's why the user agent is cert util now. And now let me go to the seventh one. No, this specific packet capture only contains 6 TCP handshake, six TCP communication. So in the sixth one, actually I stuck at this point, and I got some help from a write up. I'm admitting it. So what I did is I was actually referring all the files that I downloaded here. All these files I examined, nothing I've got, but finally the write-up said this specific file name you can see JBKEE62NIF. You can see these characters. It looks like some encoded, some interesting list of characters. So we need to investigate the specific characters, the specific string. And to do that, I am actually choosing this follow TCP stream, and I'm going to copy this specific file name. And let's investigate what sort of encoding it is, whether it is an encoded value or what it is. So let's see that. I'm using the cyber chef to achieve it, to know the encoded stuff, and I am putting that encoded thing in input, and the recipe is magic. So that is what I have newly learned from this specific exercise. When you are using the magic recipe, it will automatically examine the encoded text, and it will give what sort of encoding it was. And you can see the result here. Actually it is base 32 type of encoding, and you can see the result here, the decoded value. So this is what the flag that we wanted, and you can see it is base 32, right? So instead of using magic 32, if you know it is magic, it is base 60, base 32, then you can directly apply base 32. You will anyway going to receive the same outcome. So here is the flag. With this, you can simply submit the flag. Challenge already solved. Yeah, this was the flag. With this challenge is done. We have learned some interesting stuff here. So actually none of them accessed the web server. However, the threat actor tried to upload some malicious reversal into that web server, and they, from that reversal they tried to again reach the attacker's machine, That is how the AV alert got triggered, and the whole thing happened. So no sysadmins login, no legit login. It was completely because of an exploit attempt through a shell upload into the web server. So a thing to take away from this exercise is, whenever you are using any web server, do not expose any uploading stuff to the external world. Even if you are exposing such kind of things, enable the proper sanitizing. So whenever the user uploading anything, it has to be sanitized properly. Do not trust the user blindly. It might lead to specific or some most notorious threats. So yeah, this is what, with this we are finishing this specific exercise. And yeah, this is what I wanted to explain. Hope you really enjoyed this video. If you really did, consider subscribing my channel. You can like this video if you really liked it. And if you have any other opinion, put it in the comment section. You can also share this video among your friends. And don't forget to ring that bell to get to get notified whenever I'm posting a video. So I'll catch you next time with another exciting video. Until then, I'm signing off. Cheers, and I love you all. Thank you so much.